Hi 3E, allow me to make this video clip to continue where I left off in the classroom about center of gravity. I know there's still a little bit left. I would like to finish it up with this video clip so that you can refer to it at your own time and complete it in your summary notes. Okay, so let me start from where we left off. Looking at your notes again, we were looking at this, if you recall. Okay, we were looking at this two ways to position the box, position A and position B. How do we know by gut feeling? Like I said, this topic is a lot of common sense. How do you know by gut feeling that by this position A would be the best way to put it, to put the box, because it is more stable than the other. Okay, it is more stable. All right. So by looking at these two diagrams, first of all, you can see a difference between position A and position B. Position A, the center of gravity for position A, when you put in position A, the CG is very low, very near to the base. Okay, it's very near to the base. But for position B, the CG is higher from the base, which means stability has got something to do with the height of the CG. It seems like the lower the CG, the more stable an object will be. And this has a lot to do with moments. So that's why this topic CG comes after moment, because sometimes when we explain why a position is more stable than the other, we use moment to explain the turning effect. Okay, so let me go to the next page now. Let me go to the next page. We take a look at CG and base area. Then we try to explain it in these 3 points. 2, 3. Okay, these 3 points. So look at your notes now and watch this at the same time to explain why position A is more stable than position B. Okay, we start with tilting both. Remember, this is position A and this is position B. By position A, the way it is placed, the base area is this part. This is now called the base area. Position A was placed horizontally on the floor, so the base area is this darkened line which I put here. So let me erase again so you can see this darkened line is the base area for position A. Position B just now was placed vertically, so the base area is this lower part, which is the smaller base area. Notice? So let me erase again so you can see. So to see how both behave differently when they are tilted the same angle, I would like you to see that I have both of them tilted the same angle here, 40 degree. Both of them are tilted 40 degree. In comparison, I make sure that both angles are the same. So they are tilted 40 degree both, but they are going to give different effect. Okay, different effect. You can see that after tilting 40 degree, box in position A, when I draw a vertical line down from the center of gravity, this CG, okay, when I draw a vertical line to represent the weight is always acting vertically down from the CG, okay. So you can see this line of action, it is called the line of action of the weight, is falling within the base area. Can you see? It cuts within the base area, all right? It cuts within the base area, and because of that, and if I look at here as the pivot, then I label here as the pivot, you notice that this line of action of the weight is acting on the left side, the vertical distance. There's a a perpendicular distance between the pivot point and the force, okay, and the force. So there is a moment created because of this weight pulling it down from the left side of the pivot point. This will cause the box to fall back down this way. When you tilt it 40 degree, the line of action of the weight still fall within the base area, and it's on the left side of the pivot point, causing a anti-clockwise moment to turn this box back to its original position. Therefore, it is called stable because it falls back in the original position. Okay, I would like you to see uh, watch this PowerPoint slide that I made. Take a look. Okay, this PowerPoint slide shows position A. Okay, position A. So when I put position A this way, you notice that the line, and I tilt it 40 degree, push and tilt it 40 degree. If I tilt 40 degree, this line of action of the weight of the box, acts within the base area, and it acts on the left side of the pivot, not on the right side, the left side of the pivot. So let's see what happened when the hand let go. Okay, when the hand let go, the line of action of the weight will pull it back left side. There is an anti-clockwise moment causing it to fall backward on the left and return to the original position. Let me go back again and show. So when the hand let go, the the weight line of action of the weight will continue to pull it down, causing an anti-clockwise moment to cause the box to return back to the original position. That's why I put this side by side to let you see that original position A is lying horizontally on the floor this way or on the table. Okay, so it has come back to the original position after tilting. So we say the box is stable. Okay, let me come out of this again and go back to the notes. Okay, so I would like you to fill in this line. How is CG explained? How is stability explained using moments sometimes? Okay, so first point, when it's tilted 40 degree for position A, okay, notice position A, okay, for position A, yeah, the line of action of its weight falls within the base area. You notice that it cut within the base area. The box returns. Returns what? Returns to its original position. The next point says the weight acts on the left side of the pivot point. You can see that it acts on the left side of the pivot point here. Okay, I say again, it acts on the left side of the pivot point here. This one acts on the left side. Okay, left side. Okay, and this causes a anti-clockwise moment. It causes an anti-clockwise moment to the box. So the turning effect is anti-clockwise, causing the box to return to its original position. Okay, if there's any point that is important, it is this anti-clockwise moment causing the bag to return to its original position. So sometimes you are asked, will the box return to its original position? Yes. Why? Because the weight is acting on the left side of the pivot. Okay, the weight is acting on the left side of the pivot, and that causes an anti-clockwise moment to cause it to return back to its original position. Okay, similarly, now I want to look at B. Okay, A is done already. A is done. Now I want to look at B. Okay, look at B, and similarly, this box in this position B, which is in vertical position, now is pushed same at the same angle, tilted same angle 40 degree. However, because the CG is higher than position A, with a 40 degree tilting, the vertical line of action of the weight, the line of action of the weight now fall on the right side of the pivot point. Do you notice that? Fall on the right side of the pivot point. Okay? Fall on the right side of the pivot, which means now it will experience a different effect when the hand let go. So I would like to show you the PowerPoint slide again. Let's take a look. This time it is this position, right? This position. So the weight acting on the right side of the pivot causing a clockwise movement. So if I were to ask the hand to let go now, this vertical line of action of the weight will continue to pull the box downward this way. Because it's on the right, it causes a clockwise movement this time and cause the box to fall flat in a horizontal position, which is different from the original position, So now I say the box has toppled. If the box has toppled, then it is unstable. Okay, I repeat, In comparison to original position, this box in position B has now fallen flat on the face. It is now considered toppled and therefore it is unstable. It is less stable as compared to position B just now. So back to previously, you can see back to the same position again. When the hand push tilted 40 degree and let go, the line of action of the weight on the right side will continue to pull it down in a clockwise, causing a clockwise moment, and it will continue to fall until it falls flat on the surface. It topples. Okay. So back to the notes again. If you understand how this weight pull it vertically, causing a clockwise moment, the rest will be easy. So again, the way to explain this, how is this unstable? Why does it topple on the right side to the right side? It all begins with this. The line of action of the weight falls beyond the base area. This time the base area is smaller. I hope you notice that. The base area is smaller, having stay in the vertical position in the beginning. The box topple. Now why? Okay, why? The weight at 40 degree, at 40 degree tilting, the weight acts on the right side of the pivot. Okay, in very simple English term, the weight act on the right side of the pivot, and thereby causing what? There is a clockwise moment. Okay, there's a clockwise moment turning the box to the right. Okay, turning the box to the right side, which is causing the box to topple. So whether it return back to original position or topple to the other side, we can always use moment to explain. Before you use moment, you always try to say about the weight acting on which side, whether the weight act on the right side or the weight act on the left side. This can be seen easily by drawing a vertical line down from the CG. I'm drawing it now. Okay, drawing a vertical line down from the CG, you will be able to tell whether the weight is acting on the right side of the pivot or on the left side of the pivot. Because whichever side it act on is important, it will cause either an anti-clockwise moment or a clockwise moment from about the pivot point. Okay, now the third one I show you is just to let you see in case you encounter this kind of diagram in the 10-year series or in the O level. Whenever you draw a vertical line down from the CG, which is the weight, and it cut just neatly, just nicely through the pivot point. If it cut through just at the pivot point, exactly, this box is said to be just about, the word is just about to topple. Okay, just about to topple. So if I give you different point of CG, like for example, A, B, C, then D. And then I ask you, in this position, this box is just about to topple. Which is the CG of the box? Is it position? Is it point A, point B, point C, or point D? If I tell you the box is just about to topple, which position is A, B, C, D is the CG of the box? The answer would be A. Okay, the answer will be A. If the question say it is just about to topple, how do I mean the answer will be C. Okay, the answer will be C. How do I know the answer is C? Because when I draw a vertical line down, it cuts through the pivot point exactly. All right. Okay. Now let's come to the last point here. A simple demonstration of CG and mass. So we have looked at a few things. You see, we have looked at CG from its position from the base, whether it's low or high, the CG, whether it's low or high. Okay, it seems like the low CG will give you will be more stable, will help an object to be more stable. Higher CG will be less stable. And then we also compare base area. Okay, CG and base area. It seems like when you put in position B, position A, position A, you have a larger base area. Because of the larger base area, your line of action of the weight easily fall within the base area to cause the object to fall back to the original position. Okay, a smaller base area will cause but the line of action of the weight to fall outside the base area, and then it will cause the object to topple. Okay, That's why when you build something, you want the things that you build, let's say a bookshelf, or you want to design a wine glass or a standing fan, you want to make sure that the base is heavy as well as broad, big base area and broad base area. Okay, all right. So this all this will help to increase the stability of an object. So let's look at two scenario. These two scenario. Scenario one, comparison between wine glass, wine bottle A and wine bottle B. Scenario B, scenario two, looking at an empty wine glass and a filled wine glass. Okay, filled wine glass. Now I want to ask you for this scenario A, okay, A and B, which wine bottle is more stable? One is empty, one is filled with water. Your common sense will tell you what? I mean your instinct will tell you what? The answer will be B. B will be more stable. Which one more stable? B more stable. Why? Because when it is empty, the CG could be here, the empty, somewhere in the middle. But once you fill it with water, the mass, the heavier mass filled at the bottom, now the CG is shifted to the bottom here. You have inevitably lowered your CG from position A to position B, which is lower. Whenever you manage to lower the CG by making the base heavier, you will make that object more stable. That's why standing fan, okay, standing fan, the base, if you ever fix up or install a standing fan, the base, you go and feel the base is added with some metal load inside, a mass inside, to make sure the base is much heavier so that the standing fan won't fall easily. Okay? All right. Okay, next, let's look at the wine glass. This one is another interesting question that I came across. Wine glass, when it's filled with wine, the water is filled up at the top here. Okay? The liquid is filled up at the top here. Yes. Now compare D and E. D and E. Which one is more stable? What do you think the answer is? Is it when it's empty or when it is filled? Okay, think about the location of the CG. If your answer is E, you are correct. Okay? Uh, Previously, when filled with water, sorry, which one more stable? Which one more stable? My question, my I said it wrongly. If you say E, it is wrong. Okay? The empty one is more stable. Sorry, my mistake. Empty one is more stable. Okay? This one, more stable. More stable. Empty one is more stable. Any reason why? When you compare, when you look at scenario one, the one filled with water, the wine filled with liquid is more stable. But when you look at scenario two, the one filled with liquid is less stable. Okay? Any reason why? Let's see. When we look at the empty glass, empty wine glass, the CG, if I want to make a comparison, is it could be somewhere around here. CG, just an estimation. The CG is around here. However, by filling it with water and the water only is filled up at the top region, the CG is shifted to the top here, following the heavier mass. It went up to the top. So in comparison, it seems like the wine glass which is empty has a lower CG than the wine glass that is filled with liquid. Therefore, now the empty wine glass is the one that is more stable. Okay? Pardon my mistake in the beginning. All right? So that's the reason why. So can you write at the side here? Write at the side here. Lower mass. Okay? Lower mass. Okay, hold on. Okay, let's look at this. Lower mass means lower CG. Lower mass. allow me to correct that a little bit. Lowering the mass by adding mass at the bottom. Okay, allow me to correct this language, sorry, this mistake here. By adding mass, adding mass, adding mass at lower region, at lower region, okay, adding mass at lower region will give you lower CG, and therefore make an object more stable. Okay, I correct my error there. Okay, but adding mass at lower region will allow you to lower the CG and therefore make something more stable. So if I look at racing car, for example, racing car is made very low, correct? Let's see, the wheel very big, okay? Wheel is very big and the car is very low, okay? The racing car is very low, near to the ground, broad chassis, the body very broad and very thick wheel. So there are two conditions it fulfills. Number two, it has a broad base area. The base area is very broad, okay? Number two, the CG is very, very low, near to the ground. This will help make the racing car very, very stable so that when it make turns at high speed, it will not topple, okay? So it will be very stable. So let's take a look. In conclusion, you have written already. In conclusion, if I want to make something more stable, I can enlarge the base area. I can lower the CG by adding mass to the bottom, okay? By adding mass to the bottom. And this, I think this picture on the right is nothing new to you. Let me enlarge. It's nothing new to you. Sometimes you go to those shopping mall that the corner that sell all the wine bottles, wine. Of course, there's sometimes they display at the corner. You will see how this wine bottle is displayed in or positioned in this way. So if this one is balanced, very well stable, with just the neck of the bottle poking through the hole here. There's a hole that it poked through. Now, where would you think the CG of this bottle would be? I'm just asking you. Where would the CG be? Would it be at let's say A? Would it be at B? Would it be at C? Or would it be at D? You know, that kind of MCQ question. Okay, where would the CG be that allows it to be stable in this position? Okay, and we are talking about the CG of the wine bottle, so ABCD has to be on the wine bottle lah. All right, so the answer, make a guess, what would the answer be? The answer would be the CG will be at B. Yes, at B. How do I know? Because if it is stable in this position, then when I draw a vertical line of the weight, it must pass through the base area, and the base area is very small, it's only here. Okay, this is the base area, and you notice if I draw the position of the line of action of the a vertical line down the weight, representing the weight, if I continue to draw it down, it would have cut through the base area within. Cut within, the keyword is it must be within the base area for an object to be stable. When I draw the vertical line of the weight, vertical line of action of the weight from the object that I want to that I'm discussing about, when I draw the CG, it must I mean when I draw the weight vertically down, it must cut within the base area, this base area, which is very small, and B is the CG, the position where the vertical line will cut through the base. All right, okay, and that's the end for this topic about center of gravity. That's how much you need to know about the center of gravity, and maybe allow me to go back up here. There's this line here that I need you to see. Okay, there's this line here. Sorry, this line here that I need you to see. Okay, you can also write this line on top by the side here. Okay, the bigger the base area, the more stable an object is. All right, the bigger the base area, the more stable an object is. Is there anything else I left off? Now, back to the top, this top part again. You remember you mark the CG here, these two regular objects CG and this one CG. Now, if I ask you, draw the line of action of the weight, you now know where you should draw the action of the weight from. The weight. Weight must be always vertical. And when you draw vertical, it must be drawn from the CG. Now that you have learned CG, you must represent the weight this way. Like this triangle also, it must be this way. Okay? All right? And of course, lamina is not so easy to see, but you notice that in this diagram on the right side, you can also mark here the CG. So CG of an irregular shape object is always vertically below the pivot point, the point of suspension. Okay, that's the end for this chapter. Remember, what's important is the definition of what CG is, how to locate a CG of a regular shape object and the irregular shape object, how to locate. Okay, then where to find the CG of an irregular shape object vertically below all the time. Okay, then how do you tell the three types of stability? One, two, three types of stability or equilibrium, and how stability has got to do with base area and CG position, lower CG position. How are they related? Stability. Okay, the lower the CG and the bigger the base area, the greater the base area. And lastly, how do you use moment? Okay, let me see. How do you use moment? This one, how do you use moment to explain whether an object topple or whether an object fall back to the original position? Okay, with this, I will close here. The next part, if there's any video, I would hope to make a video on to explaining to you those leftover problems that we haven't solved. Okay, I will first take pictures of those answers and send to you, and then I will make a video clip so that if you have looking at the answer you don't understand, you can refer to the video clip to see to hear how I explain. Okay, of course, if you have still have problem, you can always look for me in school. The reason why I'm making this video clip is because next week is the test already, and I noticed that there is no more periods I can use next week. Even our own science periods, I can't use it to teach, to continue the lesson. But this video clip is enough to round up everything. All right. So thank you and bye.